Three doomed worlds around a nearby star shed light on Earth's own destiny. According to new research, we can start writing a eulogy for 4 exoplanets around a star-like sun about 57 light years away from us. But there's no hurry. We have about 1 billion years before the star becomes a red giant and starts to consume them. The star is Rho Coronae Borealis, a yellow dwarf star like our sun. It's in the constellation Corona Borealis and has almost the same mass, radius, and luminosity as our sun. But where the sun is about 5 billion years old, RCB, Rho Corona Borealis, is twice that, which means its red giant face is looming, at least in astrophysical terms. In a new paper appearing in the Astrophysical Journal represents these results and asks some questions about what happens to exoplanets in a star's habitable zone when the star becomes a red giant. The paper is Planetary Engulfment Prognosis with the RCRB system, and the sole author is Stephen R. Kane from the Department of Earth and Planetary Sciences, University of California, Riverside. Post-main sequence stellar evolution can result in dramatic and occasionally traumatic alterations in the planetary system structure, such as tidal disruption of planets and engulfment by the host star, Kane writes. Rho Corona Borealis is both old and bright, making it a particularly interesting case of advanced main sequence evolution, according to Kane, not only because it's similar to the Sun and easily observed, but also because it hosts 4 exoplanets. Kane used stellar evolution models to try to determine Rho Corona Borealis' future and the future of its planets. 1 to 1.5 billion years. In 1 to 1.5 billion years, the star will leave the main sequence and become a red giant. Red giants can swell to epic proportions, and some can expand to 1 billion kilometers in diameter. When our sun becomes one in several billion years, its bloating form will likely consume or at least destroy all of the inner planets. Our Rho CRB is no different. It has 4 known exoplanets named Rho Corona Borealis B, C, and D and E. They're named in order of discovery, not distance from the sun, the star. The 3 planets in the most danger are E, B, and C, the closest planets to the star. The 4 planets ranging in mass from super-Earth to Jovian, all of them are much closer to the star than Earth is to our sun, and the 2 innermost planets are closer to their star than Mercury is to the sun. They're tightly packed into their inner solar system, and this is what spells their doom. The researchers show that E, B, and C are the worst position. Rho CRB can totally engulf these 3 planets. The engulfment of planets by an expanding star can have different outcomes depending on the overall architecture of the system. Planets can take decades to spiral in towards the star. On the way, they can be destroyed by evaporation. They can also be destroyed by tidal disruption when they meet the Roche limit. In that case, they add to the star's bulk, helping it puff up even more. For sub-Jupiter mass planets between 3 to 5 AU, their fate is sealed according to some research. There is no escape. But for others, despite the dire circumstances, there might be a way out. Sometimes scientific models show planets start to interact in different ways, gravitationally with one another as the star swells. As the star expands, it's also losing mass as it continues to fuse material. This creates tidal effects in the system, and in some cases, it can drive planets into mean motion resonances. It also drives them further from the star. So there's a potential escape route. It's difficult to determine so far in advance what exactly might happen, though. But if some do survive, researchers think they can survive as the star leaves the red giant branch, RGB, behind. They may even survive as the star enters the asymptotic giant branch, AGB phase. The AGB phase is similar to the RGB phase, but the RGB stars have slightly different chemistries in their cores and their shells. but the details of the star are not that critical to the fate of the planets. There's a possible escape route for some of the planets, but the same tidal interactions that can rescue a planet can also work against it. Interactions can drive a planet inward towards the star too, to an earlier demise. Researchers are actively trying to understand all of these processes by watching stars that are leaving the main sequence. To understand what might happen in the Rho CRB system, Kane plotted the star's future mass, luminosity, and radius. Kane also plotted the changes the star will go through alongside the positions of the 4 exoplanets, and that puts the peril the planets face in stark relief. So how much detail can models and simulations provide when it comes to specifics of Rho CRB and its planets? Kane explains, although all of the planets will enter the stellar atmospheres of Rho CRB, their individual prognosis is very considerably. Planet E, the innermost planet, is likely terrestrial. It'll be the first to go and will probably evaporate as the star engulfs it deeply. Its demise could be swift. Planet B is the most massive of all 4, at almost 350 Earth masses. It's more massive than Jupiter, and as it enters the star's expanding atmosphere, drag will cause it to inspiral. Its fate is tidal disruption, as it simply won't be able to hang on to itself. Planet B's fate can feed into Planet C's fate. If Planet B's material makes the star swell enough, that could hasten Planet C's demise by engulfment. The same stellar swelling and radial expansion could also hasten Planet D's demise by engulfment, all before the star leaves its RGB phase behind. Planet C and D are both about Neptune mass, and they would likely lose their mass by evaporation as they spiral in towards the star. Unfortunately, the modeling did not account for orbital dynamics, but it's possible that one planet could escape all of this mayhem. Planet D is the lone world with a chance to escape. Our model further did not include the effects of orbital dynamics, which has the potential to cause Planet D to migrate further outwards and possibly escape engulfment, Kane writes. If it does, it has a chance to survive for a lot longer, possibly in a newly established habitable zone. And what that's possible, but not likely in this case, since the inner planets of Rho CRB are engulfed prior to the AGB phase, it's unlikely that orbital dynamics will play a major role in the system during and after the stellar mass loss, he wrote. There's no way to know for certain what will happen in the system, but astrophysicists are busy watching other solar systems for clues. There's not much observable evidence for engulfment so far, but that does not mean it's not happening. The paper states, thus far, observational evidence for planetary engulfment signatures has remained relatively sparse, suggesting that either engulfment scenarios are rarer than expected, or that signature detection is more challenging than anticipated. The detailed specifics of Rho CRB may be beyond our observational reach or the reach of our simulations and models for now, but there's no denying that potential catastrophic sequences. And Kane writes, the evolution of stars through their progression on the main sequence, expansion into a giant star, and then finally contraction into a white dwarf has profound consequences for the orbital planets. Given the masses and semi-major axis of the 4 known planets, we predict the planet E will evaporate within the stellar atmosphere, planet B will inspiral, and the tidally disrupted potential further inflating star. Planet B will inspiral and be tidally disrupted, potentially further inflating the star, and planet C will be evaporated within the stellar atmosphere. Planet D's fate is a little less certain, but it'll likely be destroyed too. It'll probably evaporate within the star at the end of the AGB phase. It's possible that there are other planets within the habitable zone that have not been detected. If there are, they can survive the stellar evolution on the inside of HZ's inner edge during RGB-AGB phase, but after that, the star will be a white dwarf. These planets, if they exist, will be well outside of the HZ at that time. Part of the understanding of what happens to solar systems when the stars leave the main sequence lies in the accurate picture of their planets' populations. Giant planets on distant orbits can affect the fate of inner system planets, potentially changing their orbits and moving them to safer distances. And those types of planets are difficult to detect with the transit method, but improved radial velocity measurements in the future could find more of them. The research is particularly interesting because our own sun will become a red giant and eventually a white dwarf. What will happen to our home? It's not known, but the Earth is in jeopardy. It could be destroyed or it could migrate further outward. Either way, our solar system will never look the same. Fortunately, it's so far in the future that it's merely a curiosity to us. And this was originally published on Universe Today, and it's on Science Alert by Evan Coe. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.